I'm trying to make a smart instrument from my Hercules launchpad, an instrument that can be controlled from LABView, and I have made some progress. So what I have done is I've made firmware that listens to LABView commands and then can switch on or off PWM signals. I'll show you here how it works. This is the LABView project I made. It talks over USB to my Hercules launchpad. The language that it talks is SCPI, the standard instrument automation language, and I'm measuring the PWM signal on my oscilloscope. When I click the button here to off, there is a command sent to the launchpad that switches off the PWM, and when I click it on again, the PWM switches on. In today's video we will have a look at the LABView project. It's still a simple and straightforward example, but that doesn't matter. It shows that I can talk to the hardware and that I can control the launchpad. From now on, all options are open. You can see my LABView project here and the corresponding block diagram. The design is based on one of the standard examples of LABView called Simple Serial. The Simple Serial example just shoots a command to a COM port that asks for a device ID, and then when a device answers, the response is shown in these two fields. What I have changed is that instead of asking the ID, I'm giving a command to start or stop PWM. On the left side we have the connection settings. This is an alias for your COM port. We have a baud rate of 9600, the 8 data bits, no parity, and 2 stop bits. That is identical to how I configured my launchpad. And then I've put a boolean control here that says whether I want to have PWM output or not. If we switch to the block diagram, you can find the same controls back. What you see here are the configuration settings for the serial port. And this is the part that I made to control the PWM. I have two string constants that represent the commands that I'm sending to the launchpad. One is to turn the PWM on and one is to turn the PWM off. And let's have a look at the firmware to see how this works. I have added a pattern for PWM state commands. So when I shoot a PWM state command from LABView, it will be captured by a function that I provided called SCPI Hercules PWM state, and that one will either turn on or turn off the PWM. And that's what these two string literals do. The second thing that I've done is added a boolean control, a toggle switch, and that one will determine which of the two commands is sent to the USB port. If I toggle the switch to false, you can see that the lower string literal is passed through, and if I toggle the button true, you'll see that the upper command is sent to the USB bus. Hey, let's bring in the oscilloscope and see what happens if we run this project with the button toggled high or low. We'll start with low, so we switch off the button. I'll enable the step-by-step option of LABView and start the project, and let's see what's happening. The button is low, so it goes the lower trace. And once the command is submitted, we should see here that our PWM signal stops, and that works perfectly. Let's now switch our button high and do the same. I'm starting the command and let's have a look at the scope while it's running. Once we reach this point, we should see that the PWM signal switches high. Voila. And I'll run the two scenarios again so that you can have a look at what's happening while it's running. You'll see that if I put the button low, that this line here switches to the button line, and this static control activates when I put the button to high. This line is active and the data flows like this. So I'm going to rerun it again with the boolean control off. There we go. It switches. The data goes to the control, sends it to the USB bus, and it applies. The button toggled high, the same exercise. Now the control switches to the upper. It's this command that runs to the USB bus, and it switches on. One thing you may have noticed is that our command is not PWM state but PWM1 state, but in our firmware in the pattern you see that we have a PWM cross state, and this is a placeholder. You can use this command with any number and that number will be passed to this function here. And we can check that out by setting a breakpoint. So let's do that. I'm setting a breakpoint at the start of the function and we'll go to the debug. I'll execute the program, then we switch to LABView and we'll execute it. When everything is right, we should fall into a breakpoint just when this command is sent. You see that happening here. The command we've sent is the on command, so we have sent PWM1 state on. Let's have a look at how that command arrives in our firmware. The SCPI library looked up our command in the pattern list and called this function. We put a breakpoint there, so we have nicely stopped there. And the first thing we have to find back is the one here from PWM1, and the library has a function SCPI command numbers. If we execute that, we get an array of all the command numbers that we have submitted, and in my case I've submitted only one, and that's with the value 1. So this one here represents the one here after PWM1. With that value I take care that I find back the correct PWM register in my Hercules microcontroller. And that's done here. So now this variable here points to the correct hardware register that controls PWM module 1 of my launchpad. And then based on the parameter that we've sent, we will either switch on or switch off PWM. The parameter that I've sent is on. In SCPI we can get that parameter back by asking for the first Boolean parameter. And that parameter should be true because we have sent an on. There we go, we get a value 1. And on in our case means that we want to turn PWM on. So we write a command to turn that PWM on. So we write the right value to the hardware register for PWM module 1 of our Hercules microcontroller to turn that PWM signal on. If I step through that, you see that happening here. And that's it. At this point our firmware has turned on PWM module 1 of the Hercules microcontroller as a reaction of a SCPI command sent from LABView. And this is our endgame, an instrument that knows how to react on commands from LABView and that uses industry standards to do that.